Earlier we saw how we can use art of stat to create a scatter plot to be able to find a relationship between two variables. We also saw that we can calculate the correlation coefficient using art of stat. But now, what if we want to find an actual line that describes that relationship? What if we want to use that line to help make predictions using one variable to predict the outcome of another? Well, this is what our linear regression line is for. So we're going to do the same thing using the same data of the GPA and high school GPA. And let's do things a little bit differently. Let's say we know someone's high school GPA and we wanted to predict what their college GPA is. Well, then this would be our predictor and the GPA will be our response variable. So let's take a look. How would we do this on art of stat? Is we're going to go to the same section, association, correlation, and regression, and find the linear regression option right here. As always, we can do entering our own. You can also upload a file, but we'll just do the enter our own. And this time, because of the order matters in this case, we're going to use high school GPA as our x variable because we want to use that value to predict our y variable, which is their college GPA. So let's make sure to put the high school GPA into the first column and the college GPA into the second column. So copying the high school GPA over. And then we can do the same thing for the college GPA. And we will submit our data. So again, it's another place where we can find that same exact scatter plot, as well as get our correlation coefficient here, the same exact one that we saw before. If you want, in this plot though, we can also include our regression line. So this line that tries to get as close to all the points as possible, the best fit of all our data. So this is our line that we can use to predict. So what is the slope and the intercept of that line? Well, it's given to us here. We can now build the equation necessary to predict a college GPA based off of their high school GPA. So let's see what this equation would be. I've taken our results and pasted it here so we can use it. And you might recall back from your algebra classes, we had that equation y equals mx plus b, where m was our slope and b represented our intercept, our y-intercept. Now, in statistics, again, we see that we tend to do things a little bit differently here, but it's the same idea. Our slope is the value that we put in front of our x variable because we are increasing our y variable for every single unit of the x, and the y-intercept is our starting amount. The only difference is we like to kind of switch the order of this and change the names of these. So we put y hat is equal to a plus bx. So in this case, now our a is our intercept and our b is our slope. The only other difference we notice here is that the hat goes on the y because y is no longer a value that we're trying to get. It's a predicted value. So this hat on this signifies that when we know something for x, we can plug it in to get a prediction for y. So now it's all just about putting in our equation. So we have y hat is equal to our intercept, which is given to us, 1.043, plus our slope times x. So our slope here is 0.6283. And here we have our regression equation. This is the equation of the line that we can use to plug in some value for x, our high school GPA, and we can get a prediction for y, our college GPA. Sometimes, rather than using x and y, we choose to write it in words. For example, I might say we're going to predict their GPA, which is their college GPA, by taking 1.043 plus 0.6283 times their high school GPA. So notice we just put the actual word of our variable in, the label for our variable in, instead of the variable x. I will point out that this equation that we just wrote is also found under our linear regression output. If we select the regression line, which made the line go in here, you'll see that it actually gave us that equation here as well. The rounding was slightly different, but it's the same exact outcome. Take a second to understand this equation a little bit deeper in terms of what is this intercept and what is this slope. So if we recall from our algebra classes, an intercept we can often think of as a starting value. Right? It's when our x variable is 0. So how would we interpret this? If I want to know what does this 1.043 represent, this is just saying that our GPA for college, we would predict it to be this value if we had a 0 GPA in high school. So we might say something like, we would predict a student to have a 1.043 GPA if they had a 0 GPA, 0.0, in high school. And that would be an interpretation of the intercept. On the other hand, if we were to think about what does the slope represent? Well, the slope, remember, represents a rate of change. It's how quickly we expect our GPA to change, how much we expect our GPA to change every single time we change a unit of our high school GPA, our x variable. So we might interpret this as saying something like, we predict the GPA to increase. Why increase? Because our slope is positive, so when we change our high school GPA, it's going to go up. Well, by how much? By the slope amount. So by 0.6283. For every 1 unit increase in high school GPA. Right? So we can see that we're increasing the college GPA, the prediction for the college GPA, every single time we increase this by 1 unit. The last thing we're going to take a look at is going back over to our Art of Stat. We notice that at the top on our menu, we can actually start looking at the residual analysis of our graph. So this is going to be very useful to us when we start looking at the conditions. So in this case, what we notice is that this line, it's a great prediction, but of course, not all of these dots are going to be on the line or even near the line. So how far off was our prediction compared to our values? That's what the residuals do. When we want to see what these residuals are, this will take the difference between how far every single value was for our GPA compared to how far it was from what we expected it to be. And these residuals tell us just that. And so you're going to see that a plot of our residuals is going to be something that's very useful. So we can quickly open up that plot and analyze it as needed. In addition to that plot, we can also even look at a histogram of our residuals just by clicking the box. And one thing that we're often going to be looking at is that histogram approximately normal? Does it have that symmetric shape, which like this one does? Because this is a good sign that our regression line is doing a good job.